How to choose the correct non-destructive testing method. Module 3. Gary Pace, PE Welding Engineer, Katy, Texas. So why does NDE selection even matter? Why do we even care? Can't we just pick one and go with it? Well, not really. Grown-up time. Because different discontinuities, we're going to need different inspection methods. Some things we can just find on the surface. Some things we're going to need a volumetric. We need to go X-ray vision or ultrasound and get down inside the part and see if we left something in there. So if we don't pick the right selection method, we can miss critical flaws when we're doing things, and this can be bad. The material type is going to determine what inspection capabilities we can use. We can't use mag particle on aluminum or titanium. It doesn't work that way. Or how about inspection costs and production schedules? If we can use ultrasonic testing instead of radiographic testing, well, that's going to save us a lot of cost and production schedule sometimes. Because when we use radiography, we need to shut down an area a lot of times so we don't fry a bunch of people. And when I say fry, expose them to radiation that they probably shouldn't be exposed to. So, or we got to shut down an area so that we can take those shots on certain pieces of pipe. So when we start with this non-destructive testing, we got to understand that the inspection starts with understanding the base application of what the heck it is we're doing.
So we're going to get into choosing the proper NDT method. We're just going to look at some, this is our list. We're going to grind through this. This is going to be our slides that we're going to dig through. So we're going to take a look at these and kind of get an overview of how we choose the proper NDT method before we dive into what our NDT methods are. So let's get into a little of the thought process that goes into choosing proper NDT methods. Okay, so we're going to have to determine the material to be inspected and the types of flaws or the common difficulties that are associated with that material. What are we inspecting? Ceramics, glass, steel, aluminum, some kind of composite material. What are we looking at? So that's one of the things that we need to understand first. What is the material that we're inspecting and the type of flaws that we could possibly encounter with that material? So we also want, then after we know that, we want to talk about the material manufacturing processes and the types of flaws or inconsistencies associated with those processes. Not every manufacturing process is going to give us the same type of flaw or inconsistencies. So these are some things that we need to understand as we dive into this. What kind of flaws can be introduced into that material due to specific certain types of manufacturing processes? Cutting it, smashing it, forging it, casting it. What kind of flaws can we expect to encounter due to certain manufacturing processes?
So when we're talking about manufacturing processes, hey, what are some discontinuities that can come up? Years ago, there was a titanium shaft that I was looking at. I was just in the start of my career, and there was a mechanical engineer, same experience as me, both rookies. He was talking trash, talking about slag inclusions. And I'm like, how can you have slag inclusions in titanium? The way that it's manufactured, it's manufactured in almost a distillation type process and cast and whatever. Where are you getting this slag from? Anyways, there's no slag. Or welding, cracks, porosity, lack of fusion. These are things that we can reasonably expect to see. Forging, you're going to have laps and seams. You're probably not going to have a lot of porosity or lack of fusion in forging. Rolling, you're going to get laminations. You're probably not going to get a lot of tungsten inclusions in rolling and forming. Machining, you're going to get surface cracking and tearing depending on what you got to go. So from an inspector point of view, you really need to understand how the part was made. How did they make this thing? And understand what flaws are most likely and how did they get there. And this comes with reading and experience and understanding the processes.
And we need to know the part to be inspected. We need to determine, what are the design requirements so that we can understand what the critical flaw limits are. Because if we're talking about something like an airplane, well, our critical flaw limits are probably going to be a little bit different than something that is just going to be on the ground, a bridge or something like that. Some other type of component that if it fails, it's not going to drop, 6 miles out of the air and kill everybody and we're going to be on CNN. So, the criticality of the component comes into play. And how big of a flaw can we have in components that have a very critical nature?
And this gets back to knowing the principles and limitations of our non-destructive testing methods. No single method is going to be able to get every discontinuity. Some only can look at the surface. Some are better for internal discontinuities. Maybe there's certain types that X-ray picks up better than ultrasonic testing. Materials can limit the methods, right? We can only use mag particle on ferromagnetic, iron-based or nickel or whatever our 3 material types are that can do magnetic testing. Geometry and thickness. Certain things you can't use X-ray if you can't get a piece of film behind it. It's not going to work. And, do we have the right technician skill? Is this, this is going to be critical for our results. So what's the inspector need to know about this? What type of discontinuity are we expecting? Surface or internal? Surface or internal is going to tell us a lot on what we're going to use. Is it magnetic or non-magnetic material? What's our code acceptance criteria? What's the code going to let fly? Certain codes will let porosity fly at a larger quantity than other codes. And then cost, speed, and accessibility of our inspection. One of the big ones, and I keep hammering on this, and you guys are probably sick of hearing it, but need to understand the limitations of our NDE methods. What can it do? VT, my worldview, visual testing, particle testing, and magnetic particle testing, they're all pretty much visual testing. We just throw a little extra superpower stuff in with mag particle testing and dye penetrant testing. RT, there's limitations there. We might miss planar discontinuities depending on how we're shooting into something. Ultrasonic testing, this is the work of, it's voodoo. I'm joking with my brethren that do ultrasonic testing, and I've gone through the courses. I've got 80 hours of training in that back in the day, probably more. And ultrasonic testing is insane. It takes a lot of faith and understanding and math, and you're bouncing sound waves down there and making an interpretation. And then eddy current testing. We use that for, conductive materials and thin sections of stuff, and we're not using eddy current testing to find a defect in something that's 9 inches thick. You have to understand what your process can do and how you can utilize it.
Then we need to know the cost. The cost and availability of the NDT personnel and facilities. What are we examining? And then how much does it cost to get that examined? If we're doing non-destructive testing on, I don't know, I'm not going to use airplanes here, but a jet, well, that a lot of the non-destructive testing probably that needs to be done on jet engines is going to be expensive, And the personnel to do that, there's probably not a lot of people floating around that and facilities that are able to tackle a job like that. So we need to understand that. Or maybe you need a bridge inspector, somebody to come in and inspect underneath the bridge. Well, how many bridge inspectors do we have? Well, there's 4 of them, and they're booked out for 6 months. So we need to understand the cost and availability of our non-destructive testing, the people involved, and the facilities. Maybe it's something that's just cheap. Something like dye penetrant testing, where we can do it with spray cans. Maybe that's an acceptable way, and the people to do that, the personnel, are readily available. Or maybe it's the other end of the spectrum, where we've got to really find some specialized personnel and or facilities to deal with this. So this is what a table might look like within your organization for, list of available methods, the setup requirements, the actual test costs, and then maybe the availability. So you can see on that top row, we've got liquid penetrant, labor, and the standards for setup are pretty minor. Our labor man hours per part is 0.8, availability good. Well, we get the mag particle, its availability is in heavy use. Eddy current good, ultrasound availability not working until next month. So, and then, our preliminary setup requirements for, let's say, ultrasound, possibly extensive, normally extensive. Our labor man hours per part is just about 3 times what it would be for liquid penetrant. Some additional costs. For X-ray, you can see we've got additional cost, film and development. But anyways, you can see how we would have a spreadsheet that sets up, our non-destructive testing costs, availability for our processes that we're going to utilize, and then our test costs. So most organizations, if you're going to have a pretty extensive use of non-destructive testing in multiple processes, this might be something you need to look into. You're probably going to want to determine what standards are required and their availability. So when we talk about standards, we're talking about the verifications that are required. How do we measure what's wrong? What's our standard that we're measuring against? Do we have something that we need to utilize to get there, or is it pretty extensive or not so much? So this is something we need to look at. We need to also determine what records and controls are required. What kind of records do we need to produce from our non-destructive examination? What kind of paper trail do we need? Do we need film? The radiography film? Well, if we're shooting x-rays, we're probably going to want film on these. And other processes, you're probably going to want either some kind of photographic evidence, if there's a flaw or a defect, and a paper trail, a paper copy of what your determination or your technician's determination of what the disposition of that particular part was.
So then it gets back to our real world inspection decision factors. What's the component? What's the criticality of this? Is it, a handrail on something? Yeah, that's pretty critical. We don't want somebody plunging to their death, but we probably can get by with a little visual testing and some dye penetrant testing. Maybe if we want to get a little crazy with it, do some mag particle on it. But we probably don't need to do the full stack of radiography testing or whatever. But if we've got some kind of lifting lug, lifting eye, pad eye, weld, that if that weld breaks or fails, you're going to drop a component and it's going to punch a hole through the ship, some kind of spooling ship or oil tool, whatever the hell they do out there in the Gulf. If you're going to drop something and it's going to sink a ship or kill people, you probably want to go that extra mile. Can we get to the inspection area? How can we get to it? Maybe we can't get into it. Maybe it's on the inside of a turbine. Well, then we've got to use like a borescope or some kind of, remote inspection technology. The material thickness, how thick is this thing? You know, if it's super thick, we might not be able to use ultrasonic on it. Maybe some kind of radiography where we get out a really big dog source and punch, you know, a lot of radiation into this thing. Production schedule. How long is it going to take us to do this? You know, how long is the non-destructive testing going to take? Hey, it might cost us a little more or whatever to do ultrasonic as opposed to radiography, but it'll be quicker or whatever. I don't know. You know, these are all things that you have to evaluate. Budget and equipment availability. All right. What's available to us? And then what's our code requirement and acceptance criteria for whatever code we're working to?